Hey y'all, how's it going? Are we awake out there? No? I don't know, it can be tough. I come here from Austin, Texas, which is a very long travel. But as you can see, I was extremely prepared for my talk today, which didn't have a title. So thank you all for coming anyways, because that's pretty cool. I was asked to speak at this conference, I'd say probably a little late. And they were like, Ashley, come talk at Full Stack Fest. And I was like, heck yeah, I want to talk about WASM. I don't know, did you ever see those What's Up ads? And I was like, yeah, WASM. And they're like, Ashley, we already have 2 WASM talks. I'm sorry, we can't let you give another WASM talk. And I was like, damn it, what am I going to do about this? And so today, this is my working title. We are going to talk about the developer tools that we like and why we like them, and maybe how to think more about writing them. So the first thing I'd like to ask is, how many people here build developer tools? Wow, no hands. All right, so by the end of this talk, hopefully everyone kind of understands that every time you're writing code, you are actually building a developer tool. And so before I get started, let me tell you a little bit about myself. You may know me from the internet as AG Dubs. Here I am dressed in the classic Rust programmer garb. Our unofficial mascot is Ferris the Crab. And so here I'm dressed as a crab. But I work at this big orange cloud company called Cloudflare. But I'm also on the Rust core team, the core team of the Rust WASM working group. I built a tool called WASM Pack, where I did that at Mozilla last year. I used to work at NPM, and I used to be on the board of directors of Node. And so I've dabbled in lots of different programming communities, but at every step of the way, the thing that I've always cared about was building developer experiences. And the reason for that is that I'm not actually a formally trained programmer anyway. I don't have a computer science degree. In fact, I was a middle school science teacher in Harlem as my first career. And what I like to say is that I really like to think about thinking, especially the types of thinking that happen when people write code. And so, a little like Byron's talk, but a little bit different, is that this is a talk about how to think about thinking. So all of those awesome changes in syntax and mental models that Lee was talking about, I want to talk to you today about how you get to a place where you can see those opportunities, where you can think like that and see those changes. So I am a school teacher, and so I always thought it was kind of weird that I never get to like do Q&A, and so they have Q&A here. So please, ask questions. That's the hashtag. If no one asks questions, I probably did a bad job. So I'm going to try and say some really inflammatory things to get you all really excited about stuff. So as I said, I make developer tools. And so I work on programming languages like Rust. I helped do some work on TC39 around developer experience in JavaScript. But I also build a couple of other tools. One of these tools is called Cargo Generate. I also talked about WASM Pack. I really love building these tools because I really like crafting experiences for the end user. And so when I joined Cloudflare earlier this year, they gave me a kind of funny task. They're like, hey, please make an awesome developer experience for deploying Rust-generated WebAssembly to run serverlessly on the edge. And so if you're playing hot new tech bingo, everybody just won, right? That's a lot of word salad right there. Oh my goodness. So it's like, okay, cool, wow, great. What? How do you build an intuitive developer experience for all of these different types of technologies that are really just shaking the paradigms of how we think about web development? But, you know, I did it. So I work on this tool called Wrangler. If you happen to be someone looking to deploy Rust-generated WebAssembly serverlessly on the edge, you can do that. I named it Wrangler because I had just moved to Texas and I was trying to be cool and local, but there's lots of hilarious name collisions there, both a jean company and a car company. So, you know, naming is difficult. But as you can see here, we get a fair number of downloads, but not really. And that's because these technologies are things that people are only just getting excited about. And it turns out that designing a developer experience for that is a fascinating challenge. Even more importantly, my charge now isn't to necessarily build that experience, but it is to teach these folks who are now on my team how to do that. And I think that was even a more challenging prospect. So in thinking about this talk, think of yourselves as my team, and we're going to talk about how to think about building developer experiences. And so the way I like to do this is usually to kick off with the science. And so I asked a bunch of people on Twitter, what is your favorite developer tool? All right, and this maybe seems like an obvious question, but I actually got some surprising stuff. And I really did retweet it. And if you take a look at those numbers, those are big numbers. Like, rest in peace, my mentions. If you ask me a question on Twitter after this talk, who knows if I'll see it. 545 replies as of this morning. But people said a lot of really interesting things. So if you take a look here, this is just a very small screen cap, but these are all people who listed Visual Studio Code as their #1 favorite developer tool. And I thought that was interesting, because I've been talking about building CLI tools, I work on package managers, languages, and it went down even further to IDEs. And that was pretty consistent. Even if it wasn't Visual Studio Code, people still talked about really, really loving their IDEs. And if it wasn't their IDEs, they talked maybe about their browser, they talked maybe about Git, they talked about tools that they spent a lot of time with. And this was really great, actually. The other 2 questions in this tweet were just to distract people, because it turned out that I was asking the question kind of as a trick. Because the question, what is your favorite developer tool, actually asks 2 hidden questions. The first one is, what do you think is a developer tool? But the second one is, what does it mean for something to be your favorite? What does it mean to like something? And if you weren't prepared, as I said, this is a philosophical talk. All right, so in English, we have an idiom that says there's no accounting for taste, which is to say that there's absolutely no way to understand why someone may like something while other people don't. But that's not been my experience in tech. First off, people definitely have very, very strong opinions about what they like, but I also notice that there seems to be a pretty massive pattern in the things that people like. And so these numbers are completely made up, but this is my fundamental belief about how people decide whether or not they like their tools. Now the first thing right there, that huge big chunk, 80%, is familiarity. And what I'm saying here is you like the tools that you like because you know them. You like them because they are familiar. Now this can sometimes make people a little bit upset, but let me continue to explain. The next 10% is ambition. You like a tool because it makes you want to learn it. There's something it's going to enable you to do that you really, really want to do, and as a result, you're willing to learn it. And then the last 10% is shortcuts. Maybe for medical reasons, or maybe just because you're lazy. Either way, you might not want to like type all those words out. And so we do tend to like tools that make it easy for us to take shortcuts and get to where we want to go faster. But the primary 80% right there is a big one. We just like tools because we know them. How many people are upset about that? All right, I hear some rumblings, not so much. Well, of course, I did another science on Twitter, and I did a poll. And here I made a small mistake, which is I said ergonomics is 80% familiarity, 10% ambition, 10% laziness. And I was like, yes or no? And so a lot of people said yes, but a bunch of people said no. A lot of people actually felt it was pretty insulting that their taste in tools would be exclusively based kind of on the fact that they just were familiar with them. And this is because I made the mistake of using the word ergonomics, which is really not what I'm here to talk about today. I'm talking about tools that we love. And the reason they didn't like it is because sometimes we don't like things that are familiar. So this is my sister's dog. His name is Walter, and he does not like the balloon that is supposed to look exactly like him. And so sometimes maybe we don't like the things that are familiar, but what I'm trying to say here is that ergonomics does not mean love. All right? But the tools that we love, the things that we like, the things that we gravitate to, when we ask, what's your favorite? We reach for the things that we are deeply, deeply familiar with. And so this brings me to a fascinating problem called the Napoleon dynamite problem. Has anyone heard of this problem? All right, so if you aren't familiar, Napoleon Dynamite is a very, very strange movie about a very, very strange individual who has a pretty strange life. And this is a relatively representative example of the movie. But the problem actually comes from a computer scientist who was working on algorithms for Netflix. You know, when Netflix says, hey, if you liked this, you're sure to love this other thing. And Napoleon Dynamite blew up this algorithm. It was complete anathema. People could not understand why Napoleon Dynamite was this movie that some people liked but had very, very low predictability. So when this computer scientist ran his algorithms on regular kind of hit movies, things that people kind of generally always liked, and tried to predict how any given Netflix user would rate them, he was usually within 0.8 of a star. But with films like Napoleon Dynamite, he was off by an average of 1.2 stars, which is to say Napoleon Dynamite was such a strange kind of category-breaking movie that there was no way for us to actually be able to really measure its predictive stuff. And so what I want to say here is serverless Rust-generated WebAssembly on the edge is a little bit like Napoleon Dynamite, which is to say these kind of edge technologies that we're working on are very, very interesting, and it's hard to figure out how developer workflows will look as we look at these paradigm-breaking technologies. And this brings me to an idea called a strangeness budget. Whether you're designing a programming language or a tool, or maybe even just an interface for a program that you're working on, everybody has an implicit strangeness budget. And so this concept I took from a programmer named Steve Klabnik, who also works on the Rust programming language with me. And the primary idea behind this is that building something is very, very easy. I know programmers don't like to hear that because we work really hard to build all the cool things that we build. But building something is easy when you compare it to the need to get other people to use it. And I am very deeply motivated by building things that people use. Now, the primary reason that it's difficult to get other people to use things, despite how easy it is to build them, is the fact that learning takes time. How many people here have learned a new technology and felt that it took way too long to learn? All right, I'm seeing a lot of hands. Yeah, I completely agree for this. And this is largely because a lot of the people who build our tools really respect or even account for the value of other people's time, especially when those people are learning. And so what this strangeness budget says is, hey, you want to build a cool new thing, but you can't pick all the cool new things. You need to pick just a few, because you'll run out of that strangeness budget and people will find that it's way too difficult to map the thing that you're building to their own mental model. And so one of the things that I find frustrating about this industry is that a lot of people actually believe that programming should be hard. How many people here think programming should be hard? Awesome. All right, you are not usually on the orange website then, because there's lots of them there. But I fundamentally do not believe that programming needs to be hard. And this partially comes from the fact that I've been a teacher for a long time. And so part of my learnings from being a teacher was that teacher is nature's way of letting you know how sloppy your understanding is. And I think often what we find is we have people who build tools, but they rarely pay attention to what it would take to teach somebody else to understand it. And that's kind of fair, actually, because while programming should be easy for everyone, figuring out how to make programming easy for everyone is actually really hard. So one of the people on my team has been grappling with this issue, and they made this fantastic tweet, which is, you know, if I were programming a CLI, I would simply design it in a way that is not controversial and works for every type of user. And this is absolutely fantastic strategy. Obviously, not going to run into any problems, right? But it turns out that this is very, very difficult. And part of this is because we need to understand the needs of our users, and we also need to understand how those needs change over time. So programmers love to do things in ahistorical ways and invent things from first principles. But it turns out that everything we do is actually very, very historical. And so we have needs, and we also have needs that change over time. And so this brings me to a mathematics professor who I look up to a ton. His name is Terrence Tao. And he focuses on the question of how people learn math, and he's broken it down into 3 stages. But to kind of kick it off, how many people here have read The Hitchhiker's Guide to the Galaxy? All right. So if you haven't, in The Hitchhiker's Guide to the Galaxy, Douglas Adams writes, the history of every major galactic civilization tends to pass through 3 distinct and recognizable phases, those of survival, inquiry, and sophistication, otherwise known as the how, why, and where phases. For instance, the first phase is categorized by the question, how can we eat? The second by the question, why do we eat? And the third, where shall we have lunch? And so what Terence decides is that these phases, as described by Douglas Adams about eating lunch, are actually very similar to how people learn math and how I'm arguing that people learn how to build tools, as well as how to use them. So the 3 stages of learning go like this. The first one is this pre-rigorous stage, where we start learning formalisms so that we can form intuitions. And we learn these formalisms by exploring in a very, very intuitive way. The next phase is the rigorous phase, where we find all those formalisms we've discovered and we hold tight to them. They're the things that, like, we know we're right. These are the correct things to do. We don't have to worry about this kind of fuzzy thinking. And then the last phase, and the phase that I think is the most rare, and the one that I want to encourage us to encounter more, is the post-rigorous phase, where we actually take the formalisms that we've learned and return to those intuitions to develop new ones and explore that space further. If you're thinking about who's, coming up with the idea for WebAssembly, they are in the post-rigorous phase. And oftentimes we find that most people get stuck in phase 2. So Terence says, it is of course vitally important that you know how to think rigorously, as this gives you the discipline to avoid many common errors and purge many misconceptions. Unfortunately, this has the unintended consequence that fuzzier or intuitive thinking gets deprecated as non-rigorous. All too often, one ends up discarding one's initial intuition and is only able to process mathematics at a formal level, thus getting stalled at the second stage of one's mathematical education. And arguably, I think, if we look at the programming industry and discipline as a whole, we also often get stuck in stage 2, where things are right, and this is the correct way to do things, and it's pushing us back and making it so that we can't actually leverage the creativity that comes with taking those formalisms and pushing them back towards intuition to find those new gaps and opportunities to build these kind of edge technologies. And then I think there's even something slightly more insidious about this, which is that we develop tastes. And those tastes come often from many of our first experiences, and they come from those intuitions as we're seeking those formalisms and learning and becoming a better developer. And those tastes end up turning into formalisms, and we end up believing that our tastes are actually facts when they are not. How many people here are aware of the framework wars? All right, this is when someone says, like, oh, you use PHP, that's horrible, you're a bad developer, right? These are attitudes that exist in the world, and it's unusual to me because these formalisms, those intuitions, the tools we reached for, those are not necessarily facts, and the taste that we've developed for them are largely due to the familiarity of having picked them up at the beginning. They're not facts, yet we treat them as these formalisms in our discipline. And this runs us into a very big problem. So how many people here have ever read a specification document? All right, that's cool. So I really actually love writing specification documents and reading them. And if you've never read the HTML5 spec, it's full of fantastic things and absolutely readable. But one of my favorites is this quote here, which says, in cases of conflict, you should consider users over authors, over implementers, over specifiers, over theoretical purity. And that word theoretical purity there kind of points to these rigorous formalisms that we've come up with. And oftentimes we focus on those as opposed to thinking about the intuitions of our users. And so this brings me to a concept called the mechanism is not the model, which is something that Dave Herman, who used to be the head of research at Mozilla, came up with. And he talks about specifications in this process by saying, I see this a lot in standards and design. As we spend more and more of our time swimming in formalisms like specs, semantics, or implementations, it's easy for us to overlook those fuzzier intuitions. Just like in mathematics, rigorous tools like specs help us be precise, but the mechanism of our designs and the developer's mental model they support are two separate things. Learning to be able to move back and forth between rigor and intuition is one of the key skills of good design. And this is something I'd really like to urge us to think about today. And so when thinking about developer tools and realizing this, thinking about the stages that people go through, Bjarne Stroustrup, who writes the C++ programming language, has this rule where he says, for new features, people really insist on having loud syntax, whereas for established features, people want terse notation. And so looking here, there's actually two hidden timelines. The first is the timeline of the tool itself, so the language. Is it new to the language, or is it an established feature? But then additionally, there's the question of the timeline of the user. Are the people new to the language, or are they also established users? And so in designing the Rust programming language, we actually ran into this issue with error handling. How many people here have ever written any Rust? All right, well, you're about to see some Rust syntax, and probably one of the strangest parts of Rust syntax. All right, so we can read this code here, and what it does is we're opening up a file. All right, and so this shows the 3 developments of how you could potentially handle the error of opening that file in Rust. When Rust first started out, you can see here that we have this match statement. And that match statement runs the file open command, and if it's okay, it returns a file. But if there's an error, it will then return an error. Now, if you had to do this every time you ran into an error, it could feel very, very, very verbose. And so as Rust developed and more users became established in the language, they found this to be very burdensome. If all you wanted to do was check if there's an error, couldn't we make this simpler? And so the second iteration was the try macro. And if you don't know what a macro is, don't worry. You can kind of understand it as a function. But here, instead of having to do an entire match statement, you can run the try macro. And if you need to get the file and it's okay, you'll get the file returned. But if there's an error, it will also send that error back. And then finally, what we chose to do was it was decided that checking errors in Rust was something you do so commonly that even the try macro was a little much. And so now we have the question mark operator, which if you didn't look closely, you may have missed at that end of that file open call. And what that does is it will take the result of file open. If you get a file, cool, assign it to the variable. Otherwise, it will bubble up the error to the top of your function body. So this was a really interesting thing, and question mark operator was one of the most controversial portions of syntax for the Rust programming language. It was accepted because Rust was growing, though Rust was new, but Rust was largely made of established developers, and so the vast majority of people making the decisions in the Rust programming language were people who had used it a lot, and that's why they desperately wanted significantly more terse syntax. However, what they didn't account for was the fact that they were established in a new language, which meant that new developers were going to show up. And so this is a very common question that's asked on Stack Overflow constantly, which is, there's this syntax now that's great for established users, but can be very, very, very confusing. And this was something that Rust spent a bit of its strangeness budget on. So part of the reason we end up making decisions like these, not to say that this one was incorrect, I think it was a really interesting decision, and I think one of my favorite, but fundamentally we're very, very bad about talking about the tools we like. And kind of more specifically, we're bad at talking about the characteristics of the tools that we like. So this brings me to a concept called explicitness. How many people would say that they value explicitness in a tool or language that they use? All right, so there's a blog post here written by a friend of mine named Without Boats, who also works on Rust, and they're very frustrated by the use of this word explicit because fundamentally it actually hides many concepts within it, and when people say explicit, they often mean some different things. So I was surprised to discover that the term magic actually has a specific page in Wikipedia as it is regards to programming, and many people, ever since I think kind of the Rails days, decided that magic, you know, magic, wasn't like awesome, you know, you weren't like, yeah, magic is super great, oh, that's amazing. And in fact, they weren't even like, oh, cool, it's magic, like, I'm into it, nice. No, people were more like this when they thought about magic. Oh, and now, when we talk about magic in a tool or a programming language, it often makes us very sad. And this is why we found and gravitated toward this concept of explicitness. However, when we talk about explicitness, we're not being as specific as we should be, and as a result, we're having a lot less productive conversations than we possibly could have. And so a couple of the things that you might mean when you say explicit are first, noisy. Often people think something being explicit means that there have to be a lot of characters to type. There needs to be a lot going on there so you can really see that it's going on. But noisiness doesn't necessarily mean explicitness. Additionally, people sometimes, when they say it should be explicit, they actually mean it should be burdensome, which is to say, this is something that we don't really want you to do, and so we should make it really hard for you to do it. The second one, or the third thing that we could potentially mean is also manual, which is, you know, if you really want to do that, you should have to do each and every step by hand. And that could mean explicit, but it's a very different idea that's significantly more specific. And then lastly, sometimes when we say explicit, we actually mean local, which is to say, we want to make this change, but this change or this thing we're expressing with our program needs to happen more close to other parts of it that may have an effect. So these are 4 different words that we actually can mean when we say explicit, but rarely do we use these types of words, and often we just hear, ugh, that's magic. We're supposed to be explicit, and that is a good thing. And that's really holding back our ability to look at the tools that we're designing and make decisions that actually address the needs we have. Because at the end of the day, the word explicit really just means you can figure out a lot about your program from its source, just by looking at it. But how someone goes about looking at the source and then determining what it does involves a whole set of characteristics that we often just throw out the window by saying that we hate magic. But we are bad at talking about the tools that we like, and it's partially because we have a very bad language for it, but it's also because it's not the tools that we love. In fact, it's what the tools let us become that we really love. And so it was interesting when I had asked people what their favorite tool was, and so many people reached for Git. And I thought that was interesting. I also love Git. I use Git for all of my personal projects. I use it almost for everything. Whenever I taught classes, Git was one of the very first things I taught. But my friend Lynn here actually makes a pretty good point. You know, Git is one of those things where nobody really seeks out to learn it. When you think back to when you became a programmer, why did you want to be a programmer? Was it because you really wanted to stop sending all of those Microsoft Word docs between your group for the class project with like --1 --, this is the right version, version 2 -- Ashley's copy? No, you didn't necessarily want to become a software developer because you really wanted to learn version control, right? But it's something that almost all of us end up learning, and it's critical because it allows us to build the things we want to build. And so Kathy Sierra gives fantastic talks about user experience, and there was a moment in the Rust programming language when Rust was really trying to figure out what it should be. If you really want to get yourself into an interesting time, join an open source community and then talk about how you should market that programming language. Getting a whole bunch of nerds talking about marketing can be really, really interesting. But one of the things that we ran into is that we were marketing Rust as a programming language that was a systems programming language that was fast and memory safe and prevented data races. We were talking too much about the what of the Rust programming language instead of talking about what Rust let you do. And at the end of the day, that's the thing that is exciting about developer tooling. Not what the tool is itself, but the thing that it's allowing you to do. And so in this, how many people played Mario and know what a fire flower was? Cool. Yeah, so what we can see here is, you know, a person who's a potential customer, a potential developer, user of your tool. And then you have what you might think is actually your product, which is the fire flower. But you'd be wrong if you thought that what you actually make is the fire flower. What you actually make is Fire Mario, which is your user using your tool. And so what you really are making when you're thinking about developer tools is you are building developer experiences. And one of the things that I'm particularly excited about is I think we're in a moment in our industry where we're starting to realize that developer experience is something that really matters. We're starting to see teams actually called developer experience teams instead of just developer tools. And so that brings me to the question, all right, what even is a developer tool? And so I made this tweet a while ago, and you know that it went viral because I misspelled something in it. But here's a cartoon, and it's two women sitting on a bench, and one woman is saying to the other, "I like this painting because it has a bench." Now the humor in this is that it's kind of hilarious to evaluate a painting based on something that seems completely unrelated to the painting. And yet, it is kind of true that a painting that's easier to appreciate is a better painting. And so when I talk about building developer tools, what I say is I build benches. And I think that that's a really exciting thing. And it's because a painting that's easier to appreciate really is genuinely a better painting. And so the question I want us to ask ourselves now is, how do you discover the opportunity for better developer experience? As we heard in Lee's talk, there's a lot of awesome ways that we could be looking at our systems now and finding these holes where there's opportunities to clarify our mental model and make our understanding of the problem significantly better in a way that's going to enable us to build tools that disseminate that experience to many, many more people. And so this brings me to a post by Malte Ubel called Designing Very Large JavaScript Applications. And I really, really enjoy this post, partially because it talks about the lifetime of a developer in their career trajectory. So how many people here would say they're junior developers? Respect. You guys are awesome. How many people here would say they're just like a developer, there's no like name on the type of developer they are? All right. Senior developers? Has anyone figured out what comes after senior developer that's not a manager? Right? So this is something that Malte talks about in this blog post, and I think it helps us think about how we should think about developer experience. So for a junior developer, often the thing that you say is, I want to learn how to solve this. I don't know how to solve it yet, but I want to learn how. And then as you progress, you're like, cool. I know how I would solve this. Makes sense. And then as you proceed to senior developer, you have, I know how other people would solve this. All right? And then, of course, what comes after this? And I think this is where people, regardless of what level you think you are, people who are thinking it this next way are the type of people who are really focusing on developer experience. And I think this is the type of thinking that will help level anyone up way faster than learning any sort of framework or any sort of new language or technology, which is, I can anticipate how API choices and abstractions impact the way that other people would solve the problem. So think about that for a second. What this is saying is like, first we step, all right, we're going to solve a problem. We're going to come up with a solution. Interesting, right? But it turns out that how we end up solving that problem is going to change how every developer after us is going to think about solving that problem next. And understanding the effect of the way you solve a problem and how that effect changes how other people program is critical and is at the heart of developer experience tooling. So every day, even if you're not building a CLI tool, maybe you're not building, a new programming language, say you're building simply an interface for an API that you've written, right? Every time you make those choices as you develop those programs, those choices are going to affect other developers' choices. And in that way, every piece of code you write is actually developer tooling. And so you should choose wisely. And hopefully, some of the things that I've talked about today will help you make that better choice. So the first thing to note is that When we think about the tools we like, 80% of why we like them really is because we're simply used to them. And it's worth noting that you are going to be very different than many other people who end up wanting to use your tool. Rust is a really fascinating programming language because it's attracted not just folks from system programming using C or C++, but also people from academia, people from JavaScript, Python, and Ruby, but also brand new developers. And what each one of those developers thinks is familiar is going to be radically different, which means that those people are going to have very different expectations for their developer tooling, simply based on the fact that they are unfamiliar with many of those different paradigms. But don't sleep on the fact that 10% of why people like tooling is also because of ambition. Having a cool new idea that really encourages people to want to pick up your tooling is going to help people out. And then lastly, people really don't like typing a bunch, and so finding ways to find shortcuts is a great reason to develop developer tooling. However, it's one that I think we focus way too much on, whereas playing into people's familiarity and people's ambition, I think is significantly more interesting. New technologies that we have present challenges about how we classically think about our tools. So when I talked earlier about the fact like, oh, Rust-generated WebAssembly on the serverless edge, that's a really difficult thing to try and engage folks in because it's deeply, deeply unfamiliar. And so there's a challenge there, but there's also a really, really interesting opportunity. There's opportunities to take a look at the different communities and paradigms that those different tools are disrupting and bring them together to create a new developer experience that helps bridge those communities. That being said, every project has a strangeness budget. And no matter how disruptive or awesome you think your idea is, blowing your strangeness budget is going to make it so that people don't want to use your tools. And that can be really, really tricky. And I think one of the most exciting things you can be as a programmer is someone who builds things that other people use. Nothing's sadder than, building this whole thing just for no one to come and use it. And so focusing on that and using that as a guiding light can be super important. Your users' expectations also change over the lifetime of your tool. And that can be incredibly difficult to anticipate, especially as you're gaining more and more developers. Many of those developers join your tool as a brand new user. And so you, as someone who's been working on the tool for an incredibly long time, have blind spots. And that's why when I asked people who consider themselves junior developers in the audience, if what you're working on is developer experience, you should be surrounding yourselves with people who are new to both the programs and tools that you're working on, as well as the industry as a whole. They're going to keep you fresh and help you understand where those familiarity affordances are. And then again, your users' expectations change over their lifetime as a developer. What you think you want now is actually going to be incredibly different than the things that you're going to want later. And while it's hard to notice that and predict it, it's good to know to look at your tastes as they exist now and understand that they are going to change. Additionally, we need to get better about understanding what we like and how we talk about it, because this is how we'll be able to have more constructive conversations about the tooling that we use. And be able to improve it in ways that are significantly more explicit. So if you're one of those people who's sent out one of those tweets that's like, I hate magic, find ways to be more specific and thoughtful about the message that you're expressing, because you're going to end up influencing significantly better tools. And then lastly, remember that your tastes do not represent objective facts. We all start out with intuitions, and over time, we do learn many, many rigorous facts. However, those intuitions carry a large goal of helping us find those gaps and affordances that let us build really amazing things. And so don't forget what Kathy Sierra has said. Your product is not the fire flower. You don't build developer tools. Instead, what your job as a developer experience engineer is to enable Fire Marios. So please go forth and enable Fire Marios. If you're interested in the sources that I listed in here, I have this list, and I'll tweet this out. And then additionally, for the folks who raised their hands and said that they were senior engineers, all right, remember, you're not a senior engineer if you have no junior engineers, and it is your job to help raid those people up. So I will revise my previous statement and say, instead of enabling Fire Marios, go forth and enable Fire Mario enablers. Thanks so much.